Welcome to the #1 video on YouTube to learn about Webpack. Webpack is a tool that you will run into over and over again, so it's a good idea to learn it if you want to become a modern professional developer. Now, Webpack can look a little bit intimidating, but don't worry, it's just a tool that JavaScript developers use to do certain tasks. And a task can be, for example, minification, right? So when we go from development to production, meaning putting our website or web app on the internet for other people to see, we need to optimize our files, our JavaScript files, our CSS files. So in this video, you will learn the most common tasks that people use Webpack for. Now, very quickly, before we jump into it, what is Webpack? Webpack has really become an all-in-one tool for front-end development. It's commonly used in React, Angular, Vue projects, and that's actually also why it became so popular. It was the default bundler in React, and as React exploded, Webpack grew with it. All right, so what are some common tasks that people use Webpack for? Well, for JavaScript files, we can bundle all of our JavaScript files. Usually a front-end project is going to have quite a few JavaScript files, right? So you can imagine like one file per component, and you can take all those JavaScript files together, and with Webpack, you can get one final file, right? Or sometimes you get multiple files, also called chunks, because maybe, that could be an optimization, lazy loading, right? Maybe when your user comes to your website or web app, you load the initial chunk first, the critical chunk, right? So the critical JavaScript code. And then as the user goes through your project, through your website or web app, you load additional chunks as needed, right? So then the initial load is very fast, right? So this is called lazy loading, and it's one optimization that we can do with Webpack, right? Now we can do minification of JavaScript files. We can transpile and do polyfills, right? So this is all necessary to make it work in all the browsers. We commonly use a tool for this called Babel. You can use Babel as a standalone tool, but people generally also use it in the context of Webpack. Webpack really provides a nice workflow to do all of this in one tool. You can do tree shaking, or also called dead code elimination, right? So if you're exporting something, we'll talk about that, but if you're exporting something from a file that is not used anywhere else, Webpack can remove that. It will not be in the final output. And the cool thing is we can not only work with JavaScript files, but also other file types, most commonly CSS, because in a front-end project, for example, in React, it's very common to have one CSS file per component. So you may have like 30 different CSS files, and maybe as the final output, we don't want 30 CSS files, maybe we want one CSS file, right? So it can bundle all of those CSS files together into one complete output file, right? And we want to add vendor prefixes, right? So to make it work in all the browsers, this is the equivalent to Babel in JavaScript. We can do other things like change the pixel unit to the rem unit. That's a best practice. Maybe you want to compile Sass to CSS, or you want to use CSS Modules, right? So to make that work, we can use Webpack. Now for all files, we can also get a hash in the file name, and that's useful when you have to deal with caching, right? So those are all tasks that we can do, and it provides a really nice workflow to do all of those tasks in one tool, really. All right, so those are some common tasks, but it can do other things as well. Like it will also give us a development server, right? So that we have live reload during development, right? So when you change a file, it automatically updates in your browser, right? So it really is an all-in-one tool for front-end developers. Now, the video that you're about to watch is actually a highly rated video from my professional JavaScript course. And the best way to learn Webpack is by learning at how it actually works outside these front-end frameworks. So we're going to look at a real-world project to see the added value of Webpack. Now, try to make it all the way to the end. It's really worth it. So let's just jump into it. Enjoy. Before we jump into the actual video, I quickly want to show you why Webpack is helpful in a very simple code example from scratch. So the story of web development and Webpack actually starts with HTML, because when I type in an address here in my address bar of the browser, let's say airbnb.com, if I would press enter here, my browser, my computer would send a network request, and the first file that we get back from the Airbnb server is actually an HTML file. It is not a JavaScript file, right? So even if you're creating a React application or Angular or Vue, the first file where it all starts is still HTML, right? So even though we code in JavaScript almost 100% of the time, the entry point, the starting point of any website or web app is still HTML, right? So I'm going to start here with an HTML file, because that's where the story starts, right? So I'm going to quickly show you how all of this works. So I'm going to create a new file, index.html. The name index is a bit of a remnant from the past. So with Emmet, I can quickly create an HTML boilerplate, right? I could change the title here. That's not important for now. Now let's say in our HTML, I have a button here and I'm gonna give it a class of pagination, and maybe we also have a button for sorting. Right, let's say we have an application with these two features. Very simple example, of course. So this is the first file that we get back if you type in an address in the address bar of your browser. And then this file in turn can link to other external resources like CSS or JavaScript, right? So if I want, I can link to a CSS file, right? So I could say there is an index.css file in the same folder, right? That's the path here, right? Why index.css? You could also call it main.css or style.css. The name doesn't matter as long as the extensions are CSS or HTML. The browser will know what to do with it, right? So then this is the first file that we get back from that network request, right? And the browser is going to go line by line interpreting everything here. And then it sees, oh, we need to fetch another file. And this time it's a style sheet. It's going to make another network request to whatever the path is that we specify here. And it's going to get it back and it's going to apply the style sheet to the document here. And then of course we can have other external resources like JavaScript. And these days the websites and web apps that we create are very JavaScript heavy. So this is usually where we spend most of our time. But it is, you know, it's just an external resource like any other external resource that we could have, like CSS. Other common ones are like a font, maybe you're using Google Fonts, or like a fav icon, right? Those are all external resources and JavaScript is just one of them, right? So it needs to be linked to in our HTML. Otherwise the browser will not know of any JavaScript file existence. Now with JavaScript it's a little bit strange. We don't use link, we use script, and then we use source. And let's also call this index.js. Right, and then in here we can write JavaScript, right? Very simple example. We have a pagination button here and sorting, right? So then in our JavaScript we would perhaps call this something like pagination component, right? And then we would have a sorting component, right? So I'm showing you the beginner way, right? The naive way. I'm going to put all the components in one file, right? So here, if we want to interact with this button here for pagination, we have to select it first, right? So very quickly, pagination L, document query selector, pagination, right? And then we want to do something when the user clicks on that, let's say, right? Very common. This is the most common event that you're going to be dealing with, a click event. So you have to attach an event listener, right? We're listening for the click event, and then the function that we want to execute when that event occurs. And don't worry if you're not familiar with all of this. This is all vanilla JavaScript. This is just for explaining some concepts here, right? So we're saying execute the click handler function. This is a common name for event handlers. You use the event name and then you tack on handler, right? So this can be just a function. And then here we could have more code, right? The code that we want to execute when the event occurs. Okay, so now we run into an issue, as you'll see. So now we have the sorting component. So I can also select that because we also want to do something with that when we click on the sorting button. Right, we also have a sorting button in our HTML, and now we will run into an issue, as you can see. Right, so we want to do something when there is a click. Right, now what should the name of our function be here? Right, so the common name for this is click handler. Right, so then I would create a click handler function for the sorting component. Right, and maybe you can already see it. This is a problem, and our code editor actually shows us that this is indeed a problem because we're also using the same name here for our pagination component, right? So we have a clash of names here. We have the same variable name actually, right? And this seems a little bit silly, but in the real world, naming things in programming is actually a significant problem because as you get a bigger project or you work with multiple people, you're gonna have tons of these clashes in variable names. And the reason for this is simply because in a lot of situations, there is basically only one name that makes sense. So everyone comes up with the same name. And so you're gonna have all of these clashes, right? So this is one of the reasons why we want modularity. We want some way of shielding this code from this code. We want to have a shield around this, right? And also a shield around this, right? So we want to have modularity. Now, in the past, what people used for modularity is to basically put all of this in a function, right? And then also put all of this in a function as well, right? So that looks like this. This is called an IIFE. Right, so what we're going to do, I'll use the modern syntax for functions, right? So we have an arrow function, and I'm going to put everything in this function. I can do that, right? Well, this wouldn't work because when you create a function, it doesn't execute the statements in the function body immediately, right? We've just specified the function. We have to call the function if we want to execute the statements inside of it, right? So we want to immediately invoke the function, right? That's what IIFE stands for, immediately invoked function expression, right? So this is how you specify calling a function in JavaScript. Now, this doesn't work. We have to wrap this in parentheses. So it's going to look a little bit strange, right? So we have a function wrapped in parentheses, and then we immediately invoke it. And the only reason we're doing this is to provide sort of a shield, right? To add some modularity. So if we do this, you'll see that that problem of the clash of the variable names has disappeared, right? We don't see a red outline anymore. So I can use the click handler name in here, and I can use the same name in here because this is shielded from this, and vice versa, right? So it's basically a shield, right? So this is a quick and dirty way of adding modularity to your code base. But we're still in one file here, right? So we're still working in one file, and as your project becomes bigger or you work with multiple people, that becomes a problem. Because if you work in a team, you want to be able to divide up the work. So for example, I want to work on the pagination component and you can work on the sorting component, right? But they are now in the same file, right? So if we work in the same file, I'm going to update this, right? I'm going to save my file. Well, now you are working in the same file, but basically in an outdated version now, right? So putting everything in one file, there are other problems with that. So over time, developers have figured out that splitting up your code base into multiple files is beneficial in many ways, right? So technically, you could write all of your JavaScript, even in React, Angular, or Vue. You could put all of it in one file, actually. But there simply are many benefits to splitting it up in multiple files. Okay, so then how do we split this up in multiple files, right? This is the next step. Now we have to think a little bit about folder structure. So a common folder structure is to have a folder called source, right? And we will put all of our files that we actively edit in as developers in source. And another common folder to have is something called dist or build. We will use dist here for distribution, right? So we are in development mode here, right? So we're in the source folder, we're editing these files as developers. When we go to production, we have to make all of these files, optimized. We want to remove the white space, right? Really want to make the file as small as possible so that it's super fast to download, right? So basically we need to run a build process, get our files ready for production. And those final files will usually be put in a folder called dist or build, right? But the files that you actively edit in, these are usually in a folder called source. Okay, so that's for folders. Now to put this in multiple files, usually a common architecture is to create a file for each component, right? So here we have two components. So I'm going to create another folder in here called components, right? I can do that. And we want to have a file for the pagination component. Usually these are written with an uppercase. I can call it pagination.js. And then the other one would be sorting.js, right? And then, of course, I would put this code of the pagination component in this file. Whoops. Let's see if I did that right. Right, so this would be the pagination component. I can remove it now from this file because it's in the other file. And this would be the sorting component now. Right, so now our index.js file is empty and we have put the code for each component into its own file. And that means we can now also remove these IIFEs because we use that for modularity, right? So quick and dirty modularity. But now, because this is in its own file, this is a module basically, right? So now we get that modularity because it is in its own file, right? So, and the code that is in one file will be shielded from the code in a different file. Right, so we don't have an issue here, even though I'm using click handler in this file and a click handler name in this file. That's no issue. All right, now typically you also have a different file, some kind of common.js file, because you're gonna need things in your components that you're gonna need everywhere, basically. For example, if you have to make API calls to your server, you need a URL, right? But you're not gonna write out the URL every time completely in here and then in here as well. No, usually what you do is you put the API URL in a constant and then you use it in different files, right? You can also have helper functions or utility functions, right? These typically do a particular task that you need in multiple components, right? So that all goes in some kind of common.js file. Now the example that we will use here is simply the selectors, right? So I'm just gonna put all the selectors in common.js so we have a nice overview of all the HTML elements that have been selected. Right, so now we don't have the selectors in here anymore, but we are still using them, right? So here I'm using pagination L, right? Let me close this. So pagination L is here though in a different file, right? In sorting, I'm using sorting L, but sorting is now in the common.js file, right? So now we have to talk about exporting and importing. So how can I use this variable pagination L in a different file? Well, very simple. We have ES modules. So ES modules look like this for exporting. You simply write export in front of the variable here that we want to export. Same goes for sorting L, right? That's for exporting. And then for importing, well, I can simply write import. And usually you write it with curly braces. And then the name of the variable here that we want to import is called pagination L. Pagination L from which file? Well, the common.js file, which from the perspective of the current file here is one folder up into source, right? We're currently in components, but we need to go one folder up in source and then it's common.js. So one folder up, that's / common.js, right? And then here in sorting, we want to use the sorting L variable here. So we need to import that here. Right, one folder up from common.js, right? So we can use export and import, and this syntax is called ES modules. This is also relatively new in JavaScript. The old school way of doing it is called CommonJS modules, right? So don't be confused with the file name here. That has nothing to do with the file name. It's actually called CommonJS, and this is what you typically see in Node.js, but you also see it here on the front end quite a bit. Right, maybe you've seen this before. If you want to export something, you write like this, right? Module.export. And if you want to import something, you use require. Require. Right, so this is for importing, right? That's CommonJS syntax, but we have modern ES modules syntax, right? So we have quite a few JavaScript files here. Let's go back to the basics for a second. Right, so this is the first file that the browser will receive, right? So it's going to go line by line, interpreting everything, and it's going to see, oh, there's a link to a style sheet here, so we need to fetch this file, right? So it's going to get this style sheet, and it's going to apply it to the page, and then it's going to see, oh, we need to get this index.js file, which is this one, and this one is empty, so it's going to get this one, and then, well, that's nothing. It's just going to continue, right? All of this code here, right, is going to be, well, it's not going to be applied to the page because this is the only JavaScript file that we are linking to and it's empty, right? So it's really important to understand that all the resources that you want to be applied to the page, that the browser can basically find them from the HTML, right? So since we are linking to one JavaScript file here, once it goes through this one, it needs to be able to discover the other JavaScript files as well, right? And we can very easily do that by simply importing the components in this case, right? So I only have to write the path. So I can say import, let's say pagination. It's in the components folder, which is in the current folder, right? This index.js is in the source folder. In the current folder, so we say / go into the components folder, and then it's the pagination.js file, and also sorting. Right, so HTML is where it starts. You could say the entry point. It's gonna see, oh, index.js. So it's gonna get this file, and then it sees in this file, oh, there is a pagination.js file. So it's gonna make a network request to get this one. And in this one, it will discover the common.js file, right? So we don't need to import the common.js file in here because it will already discover them from the component files, right? So that's how it works. Now, in the past, this would not work, right? So you could not split up your code base into multiple files and then give it to the browser. The browser didn't know what to do with this, right? So in order to make this work in the browser, we had to use something like Webpack or a different module bundler, as they're called, to bundle these different modules, right, or files, but a file is seen as a module, to bundle the modules, the files, together into, let's say, one file. And then from our HTML, we could link to that one file, right? So then as developers, we could work in multiple files, and then the final output would still be one file that we could link to from our HTML, right? But these days, this is actually possible with ES modules. So browsers these days natively support import and export, right? ES module syntax. The only thing we do have to change though is to say type is module in that case, so that we turn this script, this index.js script, into a so-called module script. And there are some very non-important subtle differences between a module script and a normal script. That's not important here. But now if I would do this, this would work in the browser, right? Without Webpack, right? So I have multiple different JavaScript files, and this will work without any module bundler. Now, does that mean that Webpack is obsolete or something? Do we still need Webpack? And the answer is we still want to use Webpack. Because maybe in our final output, we don't want, 20 or 30 JavaScript files, right? We can have many more components. We can have like 50 JavaScript files. Maybe we don't want 50 JavaScript files because the browser will have to make all of those network requests to get those files. Maybe we want one final JavaScript file, or maybe we want 2 or 3 JavaScript files, also called chunks, that we can load on demand, right? And also, for example, let's say I have some kind of helper function here that I'm exporting. Right, just a helper function, whoops. Right, these usually do like one typical task, like a formatting, a date, or maybe a currency conversion, right? Typical example. Convert a euro amount to a dollar amount, right? A typical task that you need in multiple components, perhaps, right? That's a utility or helper function. And let's say that I'm exporting that from this file, right? I'm exporting this. But now let's say that I never use it in any other file. So I'm exporting something, it's taking up space, but it's never used. So with Webpack, as Webpack creates this final output bundle, it will see that. It will see, oh, it's not even used. So it will actually make sure that this does not end up in the final output, right? It's basically removing this from our code base so that our code base is smaller, which is what we want. We want the files to be as small as possible because then it's faster to download for our users, right? So this is called tree shaking or dead code elimination, right? That's one other optimization that we get from using Webpack, right? And with Webpack, we can do all sorts of other things, right? We can do transpiling, right? So I'm using an arrow function here. If a user is using an old browser, that older browser may not understand arrow functions, right? So with Webpack, we can use something like Babel to transpile this, right? So basically rewrite this into an old school way, which is basically the traditional function like this, right? And then it's understood by the older browser, right? That's called transpiling, right? And many other optimizations like minification, remove all the white space, right? Remove all the white space. Remove comments, rename the variables, right? So that the variable names are shorter. With Webpack, the cool thing is we can also deal with other file types, and most commonly that's CSS. So with React, for example, you often see that each component has its own CSS file as well, right? So we could have 50 CSS files. Maybe we don't want 50 CSS files in the final output. We want one CSS file. So with Webpack, we can bundle all of those individual CSS files together into one final CSS file. And then of course, while bundling that, it can immediately do all sorts of optimizations, right? Like removing white space, adding vendor prefixes to make it work in all the browsers, right? With PostCSS, basically the equivalent of Babel, right? We can do all of these optimizations, right? And that's for CSS. Now, for all files, it can also add hashes to the file name, right, in a final file name. That's very handy for caching. Webpack can also give us a development server for live reloading, right? So then when you change one of the files, it will immediately update the page, right? So Webpack has really become this all-in-one tool, and it provides a very nice workflow to do all of these tasks. Now we will jump into the actual course video. So in the course, we have just completed our project. So in the project, we are coding a real-world web app, and it has all of these components, right? So you can see all of these files are completely coded, right? So now we are finished coding the project, and now we want to take our project and get it ready for production, right? And you're gonna see how all of that works in a real-world web application with Webpack. Right, so the folder structure will look like this at the end. So we're still gonna have a source folder for the files that we actively edit in as developers. We're gonna have a distribution folder for the final output, you could say, right? So the final output file is gonna look like this for JavaScript. The final output file for CSS is gonna look like this, right? We'll talk all about that. And you're gonna see these other files, right? So we're gonna have configuration files for Webpack, and then two of the tools that you will commonly see being used within the context of Webpack, which are PostCSS and Babel, right? And to make all of that work, we're gonna have to run some code that other people have written, and those are gonna be so-called NPM packages. We need to download those packages, and we have to keep track of the packages that have been installed. That's why we have these package.json files. And NPM is gonna install those packages for us, and by default, it's gonna put it in a folder called Node Modules. Okay, so Webpack is a big all-in-one tool. So make sure you take some time and really get to know it by completing this video. Really try to make it all the way to the end. It's really worth it. So let's get started with the actual video. Enjoy. Okay, so we want to use Webpack, right? Now, where do we get this from? We can get Webpack on the NPM website. This is a popular website in the JavaScript world. It hosts all sorts of packages, as they're called. Webpack is a package, and we can download these packages from NPM, right? So you can see Webpack is very popular. It has millions of downloads. Now, people don't always download Webpack individually. Webpack often comes as part of like a boilerplate. Like a very popular one is Create React App, right? So if you use Create React App, under the hood, it also downloads Webpack, right? So that's included in here. And Webpack, by the way, is separate from React, right? Or Angular or Vue. It's its own thing. And the reason it became so popular was because it was actually used as the default bundler in React. And React in the past couple of years has really exploded. It has really become very popular. Webpack has grown, with it, and it has become the most popular module bundler, as they're called. Now, Webpack is actually just JavaScript code that other people have written, right? So it's just JavaScript code that we're going to download, and then we're going to run that JavaScript code. If we want to run JavaScript code on our computer, so far we've done that in the browser, right? So we've given the browser JavaScript files, and that's no problem. The browser knows what to do with that. It has a so-called JavaScript engine built in. But now we want to run JavaScript code outside the browser, right? And we need something that can run JavaScript code. And that something is called Node.js, right? So Node.js is a so-called JavaScript runtime. Right, so we can run JavaScript code on our computer with Node.js, right? So if you have not installed this yet, go ahead and install it. Now, some of you will have already installed this, so you don't have to do that again. I'll show you very quickly the setup wizard here. So here's the setup wizard. Let's see. Okay, of course you should read this. It's gonna install there. Okay, so here it shows you what it's gonna install. It's gonna install Node.js, the runtime itself. Then there is this core pack. It's a new feature. It's not important here. And then it shows here npm package manager. So we also want to have this because it allows us to easily manage those packages, right? So npm is a website that hosts all of these packages, but it also is a tool that helps us manage all of the packages that we're going to install for our project, right? So don't change anything here. And also we don't need this, so you can leave this unchecked. And then you can install it, right? So you can pause the video and you can install it if you don't have it yet. And then once you installed it, you can continue with the video. Okay, now once you've installed it, or maybe you already had it, Now in Visual Studio Code, we're going to open a so-called terminal because we want to write some commands. So what you can do here is there's terminal and we want a new terminal. Okay, and it will open up the terminal. Now it's a little bit high for me, so you can change its height, right? And what we can do here, this is a so-called command line interface. So we can write commands here, right? So usually we use our mouse. We click on things to interact with our computer, to instruct the computer what to do, right? I can click on this icon and it will create a new folder, right? But now we're going to write commands. I can write a command to interact with the computer, to give it instructions, to create a new folder, for example. Right? So sometimes developers prefer writing commands instead of clicking on things. Now, I'm using the command prompt here, right? So you may actually see something different like Windows PowerShell, or if you're on Mac, you may have Bash, right? Or maybe something else. And these are just different shells as they're called. But it doesn't matter here because all our commands here will be the same, right? So I'm using the command prompt shell. You may have a different shell, but it doesn't matter. What I'm doing here is the same as what I could be doing in here, by the way, right? So the command prompt can also be it's a standalone program. Maybe you've seen this before. Some developers prefer to have it as a standalone program, but in Visual Studio Code, it's actually already integrated here, right? So Visual Studio Code is not just a code editor. We can not only edit, files, code files. There's also a built-in terminal that we're using here, right? And there are other things that are built in. So Visual Studio Code is more of a so-called integrated development environment, an IDE. Maybe you've seen that term before, right? That's because things like a terminal are built in and it goes beyond just editing files. All right, now what we want to write here to check if Node is properly installed is simply node-v. Right, so if you write that and press enter, you should see a version number. Now it's going to be a different version, that's no problem, because you're watching this at a different time. But you should see some version number. If you get an error or if there's something else that's wrong, then Node is probably not installed properly on your computer yet, right? So you need to fix the issue. Okay, so now we want to use Webpack, right? And Webpack is a package hosted by NPM. So how do we install that? How do we download that package? Well, we will use NPM. NPM is also a tool. It's a package manager, the default one in Node.js. And we actually have to initialize our project here for NPM first, right? So what we're going to do is we're going to write NPM, right? This is a tool that comes installed with Node.js, as we've seen in the setup wizard. So we can say NPM init, right, for initialize. And it's going to ask you a bunch of questions about this project. Now, we don't need to change anything here. This is not important. So I'm going to press enter for all of them. Right, so if you press enter for all of them, what you will see is that we now have a new file here, a package.json file. And this is basically just a bunch of information about our project, right? So one of the things, we don't see it here yet, but once we start installing packages, we can also see in package.json which packages we have installed, right? And that's actually important because if you share your project with someone else, well, that other person needs to know which packages to install, right? Because our project could be depending on certain packages. And well, we need to have a description of which packages those are. So that's actually important. Now let's actually start installing Webpack then. So what we can say is npm install Webpack, and we need one other package as well. Webpack is basically just the core, right? Really the core functionality. But in order to interact with it, well, we have two options basically. We can create a new file and we can write code in order to interact with it. However, we want to write commands to interact with it. So in that case, we also need a second package here called webpack-CLI. CLI means command line interface, right? It's a different word for terminal. And then we also want to make sure that we keep track of this in our package.json file. So what we can write here is --save, and then also specifically, we are using this during development, right? So we're still in development here. We're not in production, right? Production is when it's actually live on a server somewhere and people can actually, make requests and get the files back. Here we are just on our own computer here working on our project, right? So here we're gonna press enter and it's gonna take a couple of seconds to install these packages. Okay, so then after a couple of seconds, it should be finished. And a couple of things have changed now. So first of all, in the package.json file, you will see a new key here, devDependencies. And it will show you the packages that our project depends upon, right? Webpack and Webpack CLI. Okay, and these are just version numbers, by the way. Your version numbers will be slightly different. Now, that's not important for now. Now, we also get a new file, package-lock.json. And this is an even more specific way of tracking the versions of the packages that we have installed. Right? It's not important for us here. And usually, by the way, it's not important. And then, well, we have installed Webpack now, right? But where did npm put the code of Webpack? Well, it's gonna put the code in a new folder called Node.modules. So let's open that up and see if we can find Webpack. Well, to our surprise, we see that there are many packages here. However, we only installed 2 packages, right? So how come we also have all of this? Well, let's see. Let's see if we can find Webpack here. So all the way at the bottom here, I can see Webpack. Now Webpack is a package, and every package has a package.json file, right? So we just created a package.json file here for npm. So basically npm is treating our project like a package as well, right? Now Webpack has a package.json file as well. I'm going to close our own package.json file. So here we can see that Webpack also has dependencies. So Webpack can only run properly if these packages are also installed, right? So you can see it actually depends on quite a few packages. For example, schema utils. I actually don't know what this is, but you can see here in Node modules, we also have schema utils, right? So npm automatically installs these packages for us as well, because Webpack can only work properly if it also has access to these packages, right? So it already installed, for example, schema utils for us automatically. And schema utils is a package which also has a package.json file. And this package also depends on other packages, agv, I don't even know what that is, but agv has also been downloaded for us by npm, right? So it becomes this whole tree of packages, right? So npm automatically deals with that for us. It's a package manager. Okay, so now how do we use Webpack? What do we even want to do first? Well, let's first try to bundle all of these individual JavaScript files into one JavaScript file, right? The reason we want to do that is because we can also perform optimizations by doing that. Now, before we work on optimizations, let's just first try to bundle all of these individual JavaScript files together into one JavaScript file, which will be placed in the dist folder, right? So we want to instruct Webpack to do this. So how do we give Webpack this specification or this instruction? Well, with these types of situations, you want to create a so-called configuration file. And as you'll see throughout your developer journey, is with a lot of tools, if you need to specify what they need to do, you need to create a separate file. And in the file, you specify what the tool should do, right? You configure the tool. So we're going to create a configuration file for Webpack. So we're going to create a new file here. And we will call this webpack.config.js. And the file name is important because Webpack will automatically look in the file system. When we run Webpack, it will look for a file named like this, right? And if it exists, it will take our configuration into account. So what we need to do here is we need to export an object with the configuration, right? So Webpack will simply look at what is being exported here. Now remember, we were using the latest syntax, import and export. This is called CSS Modules, right? But in these configuration files, you often have to use an older syntax called CommonJS modules, right? So maybe you've seen this before, require, right? And that's for importing. And then for exporting, we need to use module.exports. And we need to export an object, right? So this is called CommonJS modules. This is still used in Node.js as well, right? So if you're creating, right, so we can use Node.js on the back end as well, right? So if you're creating a Node.js app, you will see this quite often. However, here we're not working on the back end here, right? We're working on a front end application, but we need Node.js because we need to run JavaScript code. In this object, we basically specify the options, and it can become quite complicated with Webpack. It's a powerful tool, and with that comes a little bit of complexity, right? So we're just going to look at a standard type of setup here. So first of all, we can specify the mode, because you can use Webpack during development, because, for example, we can have a development server, right? And maybe during development, you want to bundle the files as well. Here, we want to get our app ready for production, right? So here we're going to specify mode production, right? So this will tell Webpack that when we bundle these files, that these files need to become ready for production. And based on that, Webpack will actually already automatically minify the files for us, as we'll see in a second. Now, Webpack needs to know which JavaScript files to bundle into one file. So how are we going to tell Webpack that? Are we going to give each name the names of all of these JavaScript files, and then we tell Webpack, take all of these files together? And the answer is no. That's not how Webpack works. Webpack will start from one file, the entry point. So we specify entry here, and we have to give one file here. And from that one file, it will find other files to bundle together, right? Now the entry point of our application here will be index.js, because in here we are importing all of these components, these component files. So Webpack will start here, and Webpack will look at import statements, right? So it will see, oh, it's import bookmarks. Right, so now it knows we need to use this JavaScript file as well, and it will look in here and it will see, oh, import all of this stuff from common.js. Right, so Webpack will know that this file also needs to be included in the final output. Right, so it will actually scan your files for these import statements, and it actually internally builds a so-called dependency graph. So it knows that this index.js file depends on this bookmarks file because we are importing it here, right? And it sees that as a dependency. And then this bookmarks file is importing state, these other things from common.js. So it knows that this file depends on things from common.js, right? So this file depends on common.js, right? So it builds up a dependency graph, as it's called, internally. And because of that, it can do certain optimizations. Okay, but it starts with index.js. So we have to provide the path to there. And the path to there is, let's see, we are currently here. We need to go in the source folder. So what we can do is // in the current folder, find a folder with the name source, and then it's index.js. From there, it will know which files to bundle together. And then, of course, we have to specify where to put the output, right? Where to put that one bundled file. Well, we specify output here, and this is actually an object because we can specify multiple things for the output. Now we only want to specify one thing here, which is the file name of the final bundled file. And let's actually just call that main.js. Okay, and that's actually all we need so far. I'm gonna save here. So now we have configured Webpack, right? We have given basically a specification of what Webpack should do in this file. So now when we run Webpack, it will look for a file like this and it will see, okay, I need to do this. Okay, so now the question is, how do we run Webpack, right? We have Webpack in here, right? Webpack is in here, its code is in here. And actually npm will actually create a so-called bin folder for binary with the executables as these files are called. Right, so here we also have the executable for Webpack. This is actually the file that we want to run. So how do we run that file? Well, traditionally an easy way of doing that, or relatively easy, is actually to go in your package.json and it's to create a script. Right, so we can write scripts here. It actually already gives us one test. We're not going to do anything with this, so we can just remove it. But what we can do here is we can create a new script, and it's a JSON file. So I'm using double quotations here to match the other quotation marks. So we will create a new script. I'm gonna call it build. Right, it's a build script, and then the actual script itself, we can just use the package name to run that executable file. Now we can specify options here actually. Right, so with Webpack, you can give some additional commands here. For example, Webpack build, and this is actually the default, right? So we want to build our project, and so that's the default. So we don't have to specify that. The only thing we actually have to specify here is the package name, Webpack. So that's our script now. So make sure you save that, by the way. If you're following along, make sure you save it, because now we're gonna go in our terminal here, and now we're gonna run that script. Right, so we can say npm run build, and it will run Webpack. Right, so let's see if that works. Let's see if we indeed see a new file in the dist folder. So I'm gonna press enter here, and well, that looks pretty good because we see green colors here. That's usually a good indicator. You know, there's some other things here. It's not really important for now, but we do see in the dist folder that we have a new file now, main.js. And if we open that up, we can see that this is all our JavaScript code, right? It's been taken from all of those individual JavaScript files. It's been bundled into one file, right? And it's been completely minified. All the white space is gone. Even the variable names have been shortened, right? So this is, of course, very difficult to read, right? But this is what you would use in production, right? Because this file is as small as possible. This is not suitable for development, right? Because as developers, we want to have an easy time editing our code. So it needs to be readable. It needs to be easy to edit. This is not easy to edit, right? But this is perfect for production. It's pretty optimized already, actually, right? Now, about running a package, you know, you can do this. This is perfectly fine. And the advantage of this is if you share this with other people, you all have the same script, right? So you all have, you know, the same way of running packages, I guess. And if you need to provide other commands, like it's a nice interface basically for everyone on the team. But we also have a modern way of running packages. I'm actually going to delete this file from dist folder. Right, that's no problem because we can run Webpack as many times as we want. It will always create the same file, so we can just remove it. So now I want to run Webpack again. We could write npm run build again. We can use npm scripts again, but we have a modern way called npx. So with npx, the idea is that you can run packages. So you can just write npx and then the package name. Right, so we don't have to create a whole script here. We can just use npx and it will run that package. Right, so let's actually try this npx Webpack. I'm going to press enter here, and we should get the same result. And indeed, it looks similar. So now I'm going to open it up, and indeed, we get the same result. Right, so with npx, it's just easier to run a package. Right, so that's what we'll use. So now we have bundled all of these individual JavaScript files together into one file. And Webpack automatically did one optimization already, which is minification. And that's because in the configuration file, we have set the mode to production. So Webpack knows that this bundling is for production, and for production you want to have, the smallest possible file size, right? So if you would do development here, it would not minify it, because during development we need easy to edit, easy to read files, right? So that's an out-of-the-box optimization. But now we want to do some more optimizations. And one good optimization to do is to make sure that our JavaScript code, right, our JavaScript code here also works in older browsers. We have been using modern ES6 and beyond JavaScript. So for example, we've been using const and let and the arrow function. You can actually see it here. There's an arrow function here. There's also use strict here, by the way. That's not important for now. This is apparently also automatically added by Webpack. It's not really important, but you can see that we have arrow functions. You can even search for it like this. You can open the search field, by the way, with Control F. And let's see if we can see that here, or it's blocking the view. Yeah, so here, for example, there is a arrow function, right? Now, those new features may not be supported by some older browsers. There is a website called caniuse.com. If you've ever worked with CSS or you've gone through my CSS course, you can use this for CSS to check certain CSS features as well. But we can also look for JavaScript features. So for example, we've been using the const keyword for variables, right? So if you look for that, you can see const. Well, globally, almost all users are using a browser that supports this. So about 98% of users will not have an issue with this. But you can see here specifically for Internet Explorer, for example, that on a very old Internet Explorer, this simply doesn't work, right? Even on Internet Explorer 11, which still has pretty substantial global usage, right? 0.85%. It only has partial support. All these older browsers of Chrome, Firefox, Safari also seem to have certain issues with this. And same goes for let, by the way, right? Let actually has even slightly less support. And we've also been using arrow functions, right? Instead of the traditional function, right? So you can see the arrow function is not supported at all in Internet Explorer, right? So the browsers to pay attention to, by the way, are mostly Edge. This is actually from Microsoft, right? So Microsoft initially had Internet Explorer. They've abandoned this. They now have a new browser called Edge, and they seem to prioritize this more. I think they want to compete with Google Chrome. Edge is pretty good, and it's gaining market share as well. So Edge is important, Firefox is important, Chrome, Safari, and that's all for desktop. Then on mobile phones, it's mostly Safari on iOS, and I guess Chrome for Android, right? So what we want to do is, for example, if we have an arrow function like this, we actually want to simply rewrite this into the traditional format, right? So we have function, click handler, event, right? So if we would just rewrite it into this format, the older browsers will understand this, right? Now we are not manually going to rewrite this ourselves. And this is just one example. Arrow function is just one example. We have const here, right? So we should also rewrite const into var, right? There's all sorts of transformations that we can do ourselves manually, but of course that's not efficient at all. So we're gonna use something called Babel to take care of that. Babel is a transpiler. It will simply convert this into those traditional formats, right? And that's the most popular tool to use for this type of work, right? And the code will work the exact same, right? We're simply going to change the syntax, right? And we as developers will continue using the modern features because we prefer using the modern features. It makes us better developers. It allows us to write better code more easily. So we want to use modern features, but during the build process, we have to make sure that it will also work on older browsers. Right, so we should probably not be seeing arrow functions in our final bundle here. It depends a little bit on what specific browser version you still want to support. If you want to support relatively modern browsers only, arrow functions in the final output will probably be fine, right? So it depends a little bit on what specifically you still want to support. Okay, now we will use Babel to convert to transpile the modern syntax back to the traditional ES5 syntax. So we need to install Babel. So we actually need to install 3 packages. So we will go to our terminal and we will say npm install. Well, we need a couple of things actually. So we need add babel /core. Well, this is basically Babel, the actual core functionality. But with Babel, you can actually have a lot of options. So there are also presets, right? So this is like a standard set of options. And we're going to use preset-env. And the last thing we also need is babel-loader, because we're going to use Babel in the context of Webpack. And in Webpack, we use loaders for this, right? So Webpack will basically crawl our files, right? Starting from index.js, it will see these imports. It will go to that file looking for imports. And as it encounters and loads these JavaScript files, we can put those files through Babel, right? And we need babel-loader for that. And we want to save this as developer dependencies. Save dev. Okay, so if you have that, you can press enter and it's going to take a couple of seconds. These package names are a little bit strange in terms of their name. At Babel, that's simply a name spacing thing that organizations can do. So the Babel organization can have core as a package name. Now core itself will already be a package name, but they can make it part of at Babel. Basically, they can still use core as a package name, right? So it may look a little bit strange, but there's like a logical there's a reason for that. It has no different functionality or anything. These are just package names. In package.json now, we should see that we have installed these 3. You may have different versions. Okay, now what we want to do is that Webpack, well, it starts, right? Entry point, it starts here, index.js. And it will look for import statements. And as it encounters these import statements for JavaScript files, we want to make it go through Babel, and Babel will transpile the code in that file. So we should probably do that. We should probably specify that in Webpack, the configuration file here. Now Webpack, by the way, will see all these imports. Whatever you're importing is a module in the Webpack world. These are also modules in the JavaScript world. But we could also have other types of files being imported, actually. We will talk about this in a second, but we could actually also import a CSS file, right? So then this would also be a module. All these files are modules in the Webpack world. I will talk about CSS. So we can specify certain rules that Webpack needs to take into account as it encounters these modules. So we can say module, and we can specify different things for a module, but the only thing we want to say here is rules, right? And this is an array. Looks a little bit strange. That's the one downside of Webpack, is it can be a little bit complicated. And in here, we will have an object for each type of file, right? So right now we're working on the JavaScript files, but after this, we're going to have an object for CSS files, right? But let's stick to JavaScript for now. We want to use the babel-loader, right? So we can say use, you specify so-called loaders here. So these loaders are run as Webpack encounters these modules, right? So you can have multiple loaders, right? So here we're only using the babel-loader, but there could be other loaders that you want to run on these JavaScript files as well, right? So that's why it's an array. Now we need to specify that this is for JavaScript files. So what we will do here is say test. We need to use a regular expression here actually, and then a comma after that. So make sure you have the comma. So regular expressions, you use these slashes. And then in here, we need to make sure that it matches the file extension of JavaScript files, right? So the regular expression here means this is for files that end in .js only, right? So not if a file ends in .css. Right, so whenever it sees an import of a JavaScript file, it knows to use the babel-loader, but there should be one exception. So we can also say exclude. We do not want to do this for any Node modules, right? So in Node modules, we also have a ton of JavaScript files, right? But if it encounters something from Node modules, we don't want to do anything with that. So here it's also a regular expression. Make sure you have a comma at the end. Here we are excluding anything from Node modules. So anything we encounter from Node modules should not go through our babel-loader here, should not be transpiled by ourselves. The idea here being is that the package maintainer is responsible for transpiling and optimizing that code, right? We should not be doing that ourselves. We should be optimizing our own files. So what we're saying here is as Webpack goes through our files, as it encounters the JavaScript files, make them go through the babel-loader. Babel will transpile them. Now remember, Babel is a tool, and a tool usually has some kind of configuration, and that is also true for Babel. And commonly, these configurations are done with a config file. There are other ways of doing it, but here we will also use a configuration file for Babel. So let's create a new file called babel.config.js. Right, so when Babel is run, it will look for a couple of files. One of the files is this. Another file name that you will see sometimes is babel.rc. Right, but we also have webpack.config, so I like to use the same name if that's possible. And here it works the same way. So you need to export an object, right? We're using the older syntax. So here we basically need to only specify the preset that we want to use, right? So you can have all sorts of options, but a preset is basically a predefined set of options. So the options are already set for us. We can have multiple presets, so it's a list, it's an array. And then we have another array. Then in here, we need to specify a string with the name of the preset package. So it's @babel preset -env, right? So you can see these configuration files, they're a little bit intricate in terms of the syntax here. It's quite nested usually, a little bit annoying to write. But now we're specifying to Babel, use this preset. Now there's one more thing actually that we also need to specify, and that has to do with so-called polyfills, right? A polyfill, right? So if you have an arrow function, for example, we can rewrite this into this, right? Because an arrow function is simply new syntax. So you can rewrite it to the old syntax, right? This is called transpiling. Now, sometimes we have something we are using a new feature like promises. So promises, remember promise, you can say .then, right? .catch. Now promises are a new functionality. It does not have an old version or something. So you cannot simply rewrite promises, right? So in this case, you actually need to add some code to your code base that will make promises work. And this is called a polyfill, when you're actually adding some code to make a new feature work, right? So we cannot simply transpile this because there is no old version of promises. It's completely new. Right, so in this case, we need polyfills. And we can also specify that here with Babel. So what we need to do here is we simply add comma, and it's an object with options. So here we will say the following. So we say use built-ins usage. So what this means is that as Babel sees these new features being used, like promises, as it encounters them, it will automatically pull the polyfill from what's called core.js. And you can have different versions for core.js. It's a package that we're going to install. We're going to use 3.0 here. But what this means is that as Babel sees these new features like promises, it will automatically pull these polyfills from the core.js package, and it will be included in the final output, right? So we do need to install core.js. So we will say npm install core-js, and we will save this as a dev dependency as well. So I'm gonna install that. Okay, so now after installing that, we now have configured Babel as well. So now I'm actually gonna remove this file. I don't need to do this because now we're gonna run webpack again, and webpack will automatically destroy the old file and create a new file. But I just want to be extra clear here that we don't have any file here right now. So now we're gonna run webpack again. So we're gonna write npx webpack, right, this time with Babel, right? So now Babel should be converting a lot of code into old code, right? So let's see if that works. So probably because I'm recording, so it's a little bit slower. Okay, we actually get an error. So let's see what happened. Unknown option preset. So something wrong with Babel config, perhaps. Okay, so I've been playing around for a couple minutes, and the bug is that this should not be preset, but presets, right? So plural, right? So seems a little bit silly, but this is the real world. This is gonna happen sometimes. So I changed this to presets, and I saved the file here. And now I actually want to clear my terminal here. So I'm gonna kill this terminal, and I can open up the terminal with Control tilde sign on my keyboard. You can also go here, terminal, new terminal again, but now we have a fresh terminal. So now I'm gonna try npx webpack again. This looks all right. There's a bunch more stuff here because of core.js. But now if you open up the dist folder, well, I see some kind of weird license thing. You may not see this. It depends a little bit on when you're watching this. Now this is not important. Let's look at main.js. As you can see here, well, we can see at least that we have var back again, right? So we don't have const and let, right? So Babel has changed that, right? So we can see that Babel has definitely changed some things. Now we do still see arrow functions actually, right? So I can even search here, and it will give me a couple of arrow functions. The default is probably that it's not targeting very old browsers, right? So it's not doing it for very old browsers. Now we can be specific though in which browsers it should target. So this is commonly done with a so-called browsers list. You can simply put this in package.json. I'm gonna do it after script here. So I'm gonna do browsers list. And here was list. Don't forget the comma after that. Here we can specify which browsers we want Babel to target. So we can say, for example, we want to make our code suitable for all browsers that have at least 0.2% global usage, right? So Internet Explorer 11, for example, has something like 0.85%. So it would be included here, right? And there are many other things that people typically specify, like not dead, meaning the browser has received some kind of support update in the past 2 years, right? We're not going to do that here. We'll keep it simple, right? So browsers list, Babel will actually automatically look for that in package.json. And there are other tools as well, like for CSS, for example, we also want to add so-called vendor prefixes, right? Those things are like WebKit, right? These things in front of CSS properties, we add that for these older browsers as well. We have a tool for that called auto prefixer. Auto prefixer also looks at this, right? So there are other tools that can use this. So now, if we, I don't have to remove these files, by the way, so we're not going to do that anymore. I'm now going to run webpack again, and we'll see if the arrow functions are still there. Okay, so now the old file, you may not see it, but the old file is destroyed, and we have a new file. And now if you go here, you can see there's no arrow function anymore. It's the traditional function, right? Now, by the way, why should you simply not support all browsers? Why not just make this all browsers? Why only, like, why this threshold? Well, if you have all the browsers, you may actually need a lot of polyfills. So it's going to add a lot of extra code, right? But you can see, well, this is completely unreadable for us, but it's now been minified and it should work on all the browsers, right? So our JavaScript has now been bundled into one file, minified and transformed to support all the browsers. Now there are other optimizations we can do, like tree shaking, right? Dead code elimination, lazy loading, right? This is just an example. We don't want to get too crazy. And this is already like 90% of the benefits, right? So that's for JavaScript, right? So far we've bundled our JavaScript files, right? Now there is one other very common type of file that you also want to optimize in your front-end projects, and those are CSS files, right? Now we have one CSS file here, right? We also want to minify this, right? And we want to add vendor prefixes, right? So for some things like box, just an example, we could have something like this. This is a vendor prefix for WebKit browsers. This will make it work in older browsers. Right, that's the equivalent to Babel. And we could have multiple CSS files. Each component could have an accompanying CSS file. That's what you often see in React projects, right? And we may not want all those different CSS files in production. We just want one file. We want one bundled CSS file in production, right? So now we're also gonna work on CSS files. This is very common. Right, and I have a whole course on CSS, so check that out if you haven't gone through it yet. Okay, now to do those optimizations for CSS, we also need to download some packages. Right, so let's do that, npm install. Now in the CSS world, if you want to optimize your CSS, you use something called postcss. PostCSS will take the CSS file and it will allow plugins to make transformations to it, right? So PostCSS is just like the gateway, and then you need plugins to actually do the transformations. We're gonna install postcss-loader because we're gonna use it in the context of Webpack, right? And with Webpack we have loaders, right? So as it encounters the CSS files, we're gonna put those through the postcss-loader, and then we have the plugins, right, for PostCSS to do the actual transformations, the actual optimizations. So we have CSS Nano. This is a package that can minify a CSS file. And then we have Auto Prefixer, which can add those vendor prefixes to support all the browsers, right? Auto Prefixer is like the equivalent to Babel in the JavaScript world. One other thing we will also do is we will replace the pixel values into the rem unit. This is also a good practice. And there's a package for that called postcss pixel to rem. It's a bit confusing, I guess, that they have postcss in the name, but that's a plugin. Okay, so now we want to save that in our package.json file as well. So if you have all of this, I'm going to press enter here. Will probably take a couple of seconds. Okay, so now we have installed those packages as well. You can see it's becoming quite comprehensive here. So how does it work with CSS? How does Webpack even pick up that we have CSS as well in our source here, in our source code? Well, remember Webpack, we have specified the entry as this file. It will look at every import statement. So as long as we have something in our code base here where it imports the CSS file, it will pick up on the CSS file, right? So we might as well just do it right here. So we can say import, right? Here we have our CSS file. It's in the same folder. So we say // and then it's the index.css file. Now this looks a little bit strange. We cannot do this outside of Webpack, right? So we can do this thanks to a bundler like Webpack. And so as it sees this, as it picks up on this, it will put the code of this through a loader, right? So now we're going to go to webpack.config. So here, as it picked up on the JavaScript files, it will put it through the babel-loader, right? But now let's actually copy all of this. And then comma, now we have an object not for JavaScript files, but for CSS files. So as it encounters CSS files, we can have a particular loader for that, right? So we can push through the code through that loader. Let's remove the exclude here, by the way. We don't need that, right? So here we wanna make the code go through the PostCSS-loader. So as it it starts here, as it first sees all of these JavaScript files, eventually it will pick up, oh, there's a CSS file, and we have a rule for that, right? It matches this test here. So it's gonna take the CSS code, it's gonna give it to the PostCSS-loader, right? So now it's up to PostCSS to decide what to do with that CSS code. PostCSS is a tool, right? Remember, with tools, we usually want to configure them because they have a lot of options and they can work in many different ways. So we do, unfortunately, also need to create a file for that. And we can use the same format. So it's postcss.config.js. So here it works the same way. Whatever you export is going to be the actual configuration. So you export an object. Now in the object, the only thing we actually want to specify is which plugins the PostCSS should be using, right? We have 3 plugins. It's a list. That's going to be an array. So we have auto prefixer, for example, to add vendor prefixes to the CSS properties, right? Now, auto prefixer, if you write it like this doesn't mean anything. Auto prefixer, well, it's going to give us an error. It will say, well, what is this? Right? So auto prefixer is a package. And we installed the package with npm, right? So npm will put it in Node modules. Now, if you want to use that package, you need to import it in this file, right? And here we don't use import, right? Here in this file, we use require, right? Require, and then we could assign it to a variable. So we could do that, but you can actually also require it here in place, right? So we can simply write require auto prefixer, right? And it will find the code of auto prefixer in Node modules. So then comma, we also want require CSS nano to minify the CSS file. And then we also want to replace the pixel values with the rem unit, right? That package was called postcss pixel to rem. Now this one though will give us a function, and we can immediately call that function because we need to pass an option here. And options are usually done with objects. So bear with me here, it's a little bit tricky, but this package wants to know which properties, like which pixel values need to be transformed. Is it only for certain properties like margin or font size, or is it for all of them? So we're going to say property list. And then here we can specify that, well, it's going to be the asterisk, meaning all properties, all pixel values need to be replaced by rem, right? But that's a whole different story, right? So this was a little bit of typing here, but now PostCSS is configured as well. So when PostCSS is run, it will actually check if there is a file with this name in the file system. Okay, so let's run Webpack again. Let's see what happens, right? So now it will pick up on the CSS file, and it should put it through those plugins. So let's see what happens. Okay, so now we actually get an error, and here we see a bunch of our CSS, and it's saying file was processed with these loaders. Okay, but you may need an additional loader to handle the result of this loader. Okay. Now, at least, by the way, we can see here in the CSS that we actually weirdly get output here in the terminal. It does have rem, right? It also has these vendor prefixes, right? It's actually 1 dash. I actually wrote it with 2 dashes. It should be 1 dash, right? So apparently it did use PostCSS, but PostCSS, right? So as it goes through this loader, it's telling us, okay, so it went through this loader, right? So the CSS has been transformed. And now what, right? So it doesn't know what to do. And it actually makes a lot of sense because with CSS, like what do you want to do with the CSS? Do you want to create a new CSS file? Or do you want to put the CSS in an HTML file, right? We can put it inline in HTML. We can even put the CSS in JavaScript. We need to specify to Webpack that it actually needs to extract it into its own file. Unfortunately, also for that, we need packages, right? So it's a little bit cumbersome. So we need to install 2 more, right? So it's going to be npm install css-loader and the mini-css-extract-plugin. And that's what we're going to save in our package.json file. This is, by the way, a very common setup, by the way. So this is not like some obscure package or something. These are very common. So I'm going to press enter here. And let's see. Okay, so they have been installed. I'm going to make this a little bit smaller. Right, so we want to use that in this file, the mini-css-extract-plugin. Because Webpack can also have plugins, and we have installed that now. So that's in Node modules, but we need to require that in this file. So here we actually need to import it. So we can say require mini-css, and it actually already gives us the suggestion. And here we can assign that to a variable, right? Whatever we get back from that import, we will assign that to a variable. This is how it's commonly done, right? So I'll write it like this, right? So this is a Webpack plugin. These are usually written with like uppercase. Okay, now this is a plugin, right? So we have loaders, and these loaders work on an individual file basis, right? So as Webpack builds that dependency graph, it encounters those individual files, and those will individually be put through the loader. But sometimes we need to do something like with the final output, right? So in this case, it needs to create a file, one CSS file with all the CSS. So here for this, we're going to use a plugin. We can have multiple plugins, so it's an array. And the plugin, well, we need an object describing the plugin. So what we get back here is actually a blueprint for that, right? So remember, we can write new in front of a constructor function or a class, and it will give us an object. Now, we can specify options in here. For example, the file name of the file, of the CSS file, the final CSS file. Right, so don't worry about the specific syntax here. Honestly, it's a little bit cumbersome. Okay, now almost finished here. So as it goes through the PostCSS-loader, it needs to go through another loader first. Right, so this is, if you look at the documentation for that plugin, this is what it recommends. So it needs to go through the CSS-loader first, and it is from right to left, by the way, right? So as it encounters CSS files, first they will go through the PostCSS-loader, and then the output of that will go through the CSS-loader. And then the last loader that we need, let's copy this. There is another loader from this, but we can simply write that plugin name .loader. Right, so quite a bit of typing here, quite a bit of configuration, but this should work. Right, so now the CSS should go through these loaders, and eventually we should see a new file here called main.css. Okay, so now we're gonna run Webpack again, and let's see if that indeed works. Okay, so it's hanging here for me. It's not giving me any results. It's probably because I'm recording at the same time, so it's a little bit too intensive for my computer. So I'm simply gonna close the terminal here. I'm gonna open it up again, and I'm simply gonna try again. So let's see if it works now. And finally, it actually seems to work, right? So now in the dist folder, I have a CSS file as well. Right, let me make this a little bit smaller. So now if I open this up, I can see that this is my CSS and it has been minified. There are vendor prefixes and let's see, the rem unit is used instead of the pixel unit, right? This is a best practice. We have completely optimized our CSS, right? And our JavaScript, right? So now we of course also need HTML. And we could do the same thing for HTML. We could optimize it, minify it, and it will be put in the dist folder. But you know, I don't want to get too crazy. This was actually these were the most important things that I wanted to show you. So I'm just simply going to copy this HTML file and I will put it in dist here. We'll paste it here, right? Because remember, every web application, every website starts with HTML, right? So you do need HTML. This is the first file that the user will receive. You know, even if you're using React, the HTML file is still where it all starts, right? And this file in turn will link to external resources like a CSS file, right? So here it's linking to index.css. Well, now here in this folder, we have main.css. So I'm going to change it to main.css and it links to a JavaScript file. Well, that should be main.js now. And remember, we were using type is module in the browser so that we could split up our JavaScript in multiple files. Right now here, we only have one JavaScript file, right? So we don't need this anymore. Now then this HTML could also be optimized, minified, and so on. We could and it will automatically be put in the dist folder, right? So now I'm manually copying it over here. You know, we could automate everything, right? But what I wanted to show you now is that we can simply open up the HTML here and it should work. It will use the optimized CSS and JavaScript files, but it should still work. Okay, so it opened up in the browser for me. You can see it has a slightly different path. And let's check it out if it still works. So I can search here. And indeed, that still works. All of this is still working. I can bookmark here, right? Still here. Go to the next page, right? I can sort by recent, okay, right? And I can also go back and forth, right? All of this is still working. Here we have the bookmark, okay, right? But you can see all of it works and it's using the optimized files now. Right, so this will be much faster to download in production than the older files that we have here. And it will also work on older browsers, right? So these would be the final files that we would actually serve in production, right? So when someone types in the domain of our website, we would send back this HTML file and this file links to this optimized CSS file. So then the browser will make a network request to get the CSS file. The browser will also make a network request to get this optimized JavaScript file. So well done. This was an example of a build process with Webpack. There are other things we can do, but the things that we've done here are like 85% of the benefits. These are the most common things you want to do. So well done. We are now completely finished with this project. It wasn't easy. This was really difficult actually. It was pretty advanced. So if you're confused by a couple of things, that's totally normal. So congratulations on finishing this project as well. Alright, that was it for this video. Hope that you learned a lot. Now, if you liked the video and you want to become a professional modern JavaScript developer, then definitely check out the full course. It has 2 beautiful real-world projects that we built from scratch, and you will learn much more like fetch and promises and async await, destructuring the spread operator, advanced JavaScript, how to structure or architect your projects, modern front-end concepts like components, state and rendering, and much more. It's all in there. Check it out. The link is in the description. In any case, thanks for watching and I hope to see you soon.